Hey everybody, and welcome to the tutorial that is named How to make your real robot follow a trajectory on Unity. How to make your real robot follow a trajectory on Unity. It's part of a series on making autonomous racing drones. You can see our GitHub at Alpha Pilot France. Right? We will be essentially moving a robot, a Turtlebot3, not any robot, Turtlebot3, following a trajectory on Unity. So as you have the Unity Jeep move in, it converts information and transfers it into the Turtlebot. Not too simple. As you can see, alright, when it moves straight, the Turtlebot moves straight. When it turns, the Turtlebot starts turning. As you can see, there we have it turning. Okay. So, you can create a path and play the simulator. This video will look at playing the simulator. The simulator is here on Windows 10, and you can see it right here. We'll get to it. The information needs to be transmitted through ROS, Robotic Operating System. Robotic Operating System helps move the robot, and this bridge goes into not Windows, but Ubuntu. Alright? And this information of velocities and angle is fed into a Python script to create the twist angle for the Turtlebot. So to do this, we need a virtual machine. We set it up in the previous tutorial, Ubuntu 16.04. We also set up Rust Kinetic, right, in the previous tutorial. We've downloaded some Catkin source files, but I will show you how to. Eventually, you can go to okay. We will set this up, configure the messages, each message from here, in here, and the messages output. Alright, and then we set up the Python script to execute a simulated demo. Alright, so having said that, prerequisites of the Turtlebot3 quick kit that we set up in the last tutorial, and a PC Windows with Ubuntu VM from VMware. Player 15 for the VM. So, it can actually be anything. Alright, so we get back here and we get started. That was quick. Now, this connection between Windows and Ubuntu is managed by the well-maintained ROS Sharp repository. So you'll have a link in the show notes, but I'll just put it here for now. But it comes from the ROS Sharp Siemens repository. Siemens. And you can find it here, right? So it's the ROS Sharp Siemens repository. The other thing is, so I'm just going to stick it in here. The other thing is, you can definitely have it all explained in the Rostrap Unity simulation scene. If you don't want, if you prefer to watch that, so that's the other resource that we have here. Let's get to work. Okay. So we are going to start with the connector script. Let us enter into Ubuntu. Alright, so I've just followed the tutorial here. It says install ROS Kinetic ROS Bridge Server. I've installed that now on an empty terminal, and the file server package needs to be placed in the source folder, and cat can make needs to be done. I do believe that if I go to Catkin workspace, home, right, the file server file is here because we downloaded it, but you are welcome to do so yourself. Alright, and from here on, we can directly we'd like to install another GitHub, which is Unity Simulation Scene, which also falls under right, so we have to install Raspberry Suite. We will put it into the here, cd source Raspberry Suite. I believe that we have it. Just need to find it. Here it is. To go in here and to find the right files. Unity simulation sim. Let me just check this in. Sudo apt install Python excellent, definitely. And let's make this, let's take the Unity simulation scene. Let's just download the entire ROS shard. All of ROS shard. Let's do this. Okay, so ROS shard should be installed here. We can look into here on install colon Unity3D assets, ROS shop, scenes. Actually, got your ROS. Here we go. We take that out and we stick it into, here we go, instead of here. So let me just delete this quickly. And stick this in here. That being said, alright, let's do a quick Catkin make. And speed this up. Alright, and let's launch. Unity simulation scene. Unity simulation scene dot launch. Alright. We cannot locate master joy in package. Master joy needs to be made executable. But we do not need this for our purposes. We are not trying to. So let me explain. This was part of a tutorial where they were trying to configure the position of your mouse in the Ubuntu window. So if it's here or here or here or here, and take it and subscribe to it in Unity to publish the direction of your simulator and be able to visualize the position. But we will be using the simulator in order to control the Turtlebot, something different. So this is done. I'm glad of that. Let us begin this simulator. In the next video, we will look at how to create a simulator of this type. Right. But with different parts. But in this case, we are going to get this started. Alright, so this is moving. Let me stop this quickly. There is something we forgot. The Rust connector. Now, if you do open another tab, if you do look at the inspector, there is the Rust connector needs to be connected to the right WebSocket. In our case, to check the WebSocket of your Ubuntu, you need to ifconfig 4133. So change this to right. I hope this works now. Right. And now this should be connected. As you can see, it is connected. Alright. This is now publishing information like odometry of the vehicle. You can see it when you simply look at the list of topics that are published. There is the odometry, which is published directly from the Rust connector, as you can see right here, and Rust topic echo. Alright, so if you Rust topic echo my odom, you get the odometry position and orientation, and if you Rust topic echo the velocity vector, which is time correct velocities right there, you get the velocity values in linear and angular form. Alright, from these topics we create a Python script, which you can find at source Unity follow. Let's explore the Python script in more detail. Right, so we are publishing what's quite a long script with inferior ideas, but we are taking information. As you can see here, we're subscribing to the velocities and to my item, and velocities, and from there creating a velocity vector for our Turtlebot. Alright, so let's look at my item. My item is a post and type vector that triggers the new item function. New item function really essentially takes the position and the angle, of which we are only interested in theta, and it updates it regularly. As for velocities, the wheel twist function updates x and y. Alright, one little detail here about rotations is that maximum rotational velocity cannot be higher than 2.84 rads per second. Alright. We take these information and do our conversion. Now this conversion is quite simple. Let me draw it up. Alright, imagine your robot on the simulator is, well, both robots are moving in a certain direction. Alright, and we do want to know what the speed is, and we do want to know the angle of rotation. Alright, to do this, the information that we're given really is an x velocity and a y velocity. Alright, and perhaps even an angle of attack. Alright, so if this is your x velocity, which I'm just going to call x dot and y dot, the best way to conceive of, let's call this forward velocity, and rotational, right, is that forward velocity is equal to, well, as you can see, x x cos theta plus y sine theta. And rotational, well, we will get to rotational, but that's the initial formula, which we will calculate using the information we have, and this is not used, as we only need the rotational y velocity, which we've gained in the velocities vector. So we insert forward velocity and we insert rotational velocity. Right, it would be safest to if to limit this velocity to 0.22 meters per second. Alright, and that is it. We publish the velocities. To execute this file, we get to, well, do not forget to ROS launch your Turtlebot with the ROS launch Turtlebot3 command that we saw in the previous tutorial. But for the Python script, cd source cd captain make I think cd captain workspace source. Alright, and Python Unity follower .py. It is oh, so much so for making one little mistake there. Okay, so much so for me trying to edit these as arrays. Not incredibly necessary. So let me just get rid of these. Leave this here. Alright, and execute the file. Right, and so this should execute. Right, on the Turtlebot, as we saw in the video. Thank you very much. In the next video, I'll show you how to do all the Unity simulations.